Hi, everybody. My name is Floyd Christofferson. I'm the VP of Product Marketing at Hammerspace. And I'm going to talk about what we've talked about before is what is a global data environment, but looking at it from a macro sense. But if we really want to peel this apart, let's break it down to how this actually applies in a data center, because the problem is still the same. And getting into the details of how actually, what are the components of a global data environment within Hammerspace. We know that users are accessing metadata. And we talk about metadata and the importance of metadata. The metadata they access is typically within a file system. You know, they're mounting it via whatever protocol they're doing. And that from their perspective, they're seeing a file system, they're seeing their files. The problem is that the data often and almost always outlasts the storage that it was born on. More importantly, the storage itself will fill and need to be replaced. And so what happens then is users are not able to, unless they're using tricks of symlinks or other things, they're faced now with another share. They have to access another set of metadata. And this continues to grow. There's no one-size-fits-all storage. There will be higher performance, lower cost, lower throughput storage, each with its different purpose along the life cycle of the data, wherever it may be. And so the problem is this begins to compound. The more silos you get, the more different islands of storage there are, and the more different islands of storage there are, which creates difficulty for IT administrators to manage this. How do they manage globally when they've got their users and the applications having to repoint? There's consequences as well in just even storage utilization. You'll get islands of storage that are oversubscribed, but because applications and users are mapped to those islands, then you can't just easily expand those into what might be incompatible other storage types. Storage vendors, when you look at it from a storage centric, they'll try to create their own global environment, but then that also creates the problems of a vendor lock. And so the flexibility for organizations becomes very difficult for them to manage this in an individual data silo. And this applies, of course, as you go out into broader schemes. So the answer to this and the way that we approach this is through bringing the metadata up above the storage layer. So what Hammerspace does in connecting to individual storage devices is we will assimilate that file system metadata up into a metadata control plane. So now, rather than the individual user or the application mapping down to the device, they're mapping to the metadata control plane. So in this way, they're now seeing the file system at a global level, disconnected from the physical data essence that will be on one or perhaps multiple storage devices or even locations below.
How does that instantiate itself? Just a local appliance, a virtual machine?
We have this is a software-defined solution that can be installed on local hardware. It can be installed on virtual machines. It can be installed in the cloud. There's the metadata control plane, what we call the anvil. And then we've got the DSX, which is the data service node, which is scale out. So for high availability within the metadata service node or the metadata control plane, that is its own thing. And then we can scale out in the back end our data services nodes as fast and as broad as we need to accommodate whatever performance. In the back end of Hammerspace is based on parallel NFS 4.2. So we've got very, very fast pipes in the back so we can scale out to virtually any. And then that enables us to map to whatever the front side access requirements may be.
But yeah, you mentioned also the possibility to have some geographic global file system. In this case, the control plane You have one in each site, or it's just?
No, the control plane that we would set up in one location is synchronous, but we can extend this out across multiple locations. We have customers that have an extended global file system across 9 data centers around the world, plus 2 cloud instances, for example, and they're continuing to grow. From all of those, they're seeing the same file system, the same files. This is very important because this is not copying data. You know, the problem when you've got individual silos in a data center is you want to make it visible across other shares. Maybe you put symlinks or you have stubbing or HSM type of legacy technologies. That's data management by copy. What we're doing is actually elevating this metadata control plane above the physical infrastructure. So back end the data can be as many instantiations as you want, but the users are accessing the same file, not a copy of the file, but the same file, right? Whether that's within a local data center or extended across multiple data centers or around the world, anywhere, right? So, and this is very important because when you're accessing and you can provide this multi-protocol access on the front side, that way users and applications, they're pointed to a file system, just like they would be if it was an individual silo, except that it's now being able to bridge them all.
NFS 4.2 is relatively new. Not a lot of these storage systems actually support it. Does it somehow, obviously you're driving this stuff in parallel from the data server, but at the storage server, are they coming in as NFS 4.2 parallel file system accesses, or are they?
We'll mount the backend storage with whatever protocol it supports. Within our control plane, within our internals, we will move data and parallelize data I/O with 4.2. You're right. The storage themselves may not support it. Also, clients on the front side may not want it. If they have it, they can go direct and get massive I/O. But that's why we aggregate and present this out through multi-protocol on the front end. So whether they're using SMB, NFS 3, 4, whatever, they will see whatever they need to see, what their applications need to see, and what they're used to seeing. On the back end, it could be S3 storage, it could be NFS, SMB, whatever.
It has to be files. It has to be.
No. We can also take over block storage, and so we've got the flexibility to take over virtually any kind of storage.
So if this stuff is globally accessible, how do you handle locking?
Within a data center, we have synchronous locking, and we're able to do this. Between data centers, it's asynchronous by design, right? Because otherwise, you have to ensure that all data centers are live all the time. So what we'll do is we'll do conflict resolution on the back end, bringing in, and Tony, if you want to add to this, bringing in versioning and other ways to resolve conflicts.
Yeah, so we do file versioning on various sites in order to address the conflict issues. What we found is that especially in a global file lock, you typically have a single source of data, and all of the remote locations have to go to that in order to get access to the data. We actually will distribute data into different locations and different environments. And a relationship in a file lock, in a global file lock, if one of the sites is down in a global file lock, everything becomes read-only at that point.
Right.
And so we were designed so that sites don't have to be available. And so we've taken the approach of a conflict resolution versus conflict avoidance.
You mentioned that in the front end or in the back end, you can have multiple protocols.
Correct.
Your metadata are just a subset, for example, from POSIX metadata and Windows metadata.
That's right.
Or S3 metadata.
That's right. If somebody's coming in through an SMB connection, the file system looks different, obviously, than if they're coming in straight NFS. So we do that translation within and present those out. It's the same data, right? It's just how we translate the protocols. We're also mapping the permissions so that they're consistent across multiple protocols as well.
Yeah, so you mentioned that you support block storage in the back end, but you're really presenting on top of that file services.
Yeah,
right.
That's right.
And you're not really assimilating the block storage and presenting block protocols in front, right?
No, that's correct.
No, you're exactly right. So we will,
Yep.
in the case where we are supporting block storage, or I should not say supporting, but leveraging it, we're going to put down a POSIX file system,
Right.
and or object storage.
That's right. So we have the ability, and this is part of the flexibility of the Hammerspace architecture, is we have the ability within to extend storage directly off of the DSX nodes for extremely high performance. And then we can take direct advantage of the NFS 4.2 and parallel IO directly to that. But have that merged into a multi-storage environment. And then what presents out the front end and how users access that is objective based. And that actually leads importantly to the next point, which is once you have this ubiquitous access across the front, then it enables you to have global data services. A big problem, especially in environments that are using copies as a way of data management, is that you'll have different backup procedures for different storage types. You'll have point solutions to move data from point to point. You'll have, any number of different things that you're all well aware of. But within Hammerspace, because the metadata control plane is ubiquitous across all data types, across all storage types and locations, it means that you can apply global snapshots across heterogeneous storage. You can apply global policies. So you can either eliminate or certainly minimize the number of individual point solutions that you need to do, which then also enables you to do global data orchestration at a file granular level. So back-end migration of retiring old storage and putting it on new, or tiering into cheaper storage, or multi-instancing for data copy management, or encryption, worming. All of these things can be done with objective-based policies. And this is a purposeful word. You set objectives for the type of policies that you want for these data and for the type of storage that it needs.
Can you do also global dedupe?
Yes, global dedupe as well. But also, don't forget, there's also more metadata than just what we can harvest out of the file system. We can also tag metadata with custom, whether it's a job number, a reference ID, a project ID, workflow stages, so that the objectives can map and be driven by a policy, a data protection policy, a compliance policy, a workflow, a staged workflow across different, where the data has to be pre-staged into different storage or into different locations.
Do you expose any API so that I can have access to all this metadata information?
Absolutely,
applications?
absolutely. And yes, exactly. Yeah, through API, through the front end as well. So you can, whether you're using monitoring or you want to plug in directly and access and script these policies directly, absolutely.
So what does a global snapshot look like in this environment? Is it that the snapshot's available and accessible globally, or is it the snapshot physically exists across multiple storage entities, data centers, et cetera?
Well, Tony, maybe you can answer that one better than I can. But what you can do is globally snap across multiple file systems as well. And, oh, by the way, we can mount those snaps and mount those so you can actually go back in time to a point in time within the snap itself. Tony, do you want to add?
Yeah, so the snapshots are at a share level, right? So we do snapshots within a share level. That share is part of the global file system. So that's what it means by global. And then we can store that snapshot. It doesn't have to be on the same storage as the primary data. It could be on object store, it could be in the cloud, et cetera. But yeah, anything at a share level has a global snapshot.
Does that make sense?
Yeah, but snapshots historically have been either complete copies, clones, or space, differential kinds of things. If you're moving the snapshot data to another storage system, you're making a clone.
Well, you're making a copy to somewhere else, which you can clone and present that as a file system as well. The key is,
are you retaining the differential characteristics of the data across multiple storage systems?
sorry,
So if I take a snapshot today and I write to it, all I have to really save is the write, and that's all I need to save. But if I'm doing it across multiple storage systems, am I doing differential snapshotting or not?
Remember, what you're looking at is at the metadata control plane layer. There may be multiple instances of the file, and we've got versions of the file, but what you're doing is snapping as well that point in time of the file system as it's presented out the front.
As Tony pointed out, snapshots, right, are share level. So it is done on a Hammerspace storage system, and they can then be moved to any other location. So it's not, I wouldn't call it a global snapshot, and it is differential.
The key here really is from an IT administrator point of view, and rather than managing by silo or managing by copy, they can manage policies across them all, set file level data orchestration across them all, so that in a sense, what we're talking about when we're talking about Hammerspace and our global file system is this stack from the ubiquitous front end through the global file system across all, down through the policies that can be applied across all and the services across all, to orchestration across all without needing symlinks, without managing by copy, all from the same shared front-end file system. So at the end of the day, what we want to make sure, and the operating philosophy here, is data accessibility. All data, whether it's within a data center or multiple data centers, needs to be accessible. You shouldn't have to jump shares. You shouldn't have to jump IP addresses. You shouldn't have to repoint applications. You need to be able to save CAPEX by being able to eliminate, hotspots in your storage, whether it be oversubscription or underutilization. You can spread out your capacity, pull off data transparently off of high performance storage downstream to cool or cold storage without interrupting user access, and then save on your OPEX so that your IT administrators are not managing a whole host of different point solutions, but they can actually take a global management view over the whole thing.
When you decide the policies where you write new data, so if you have this global file system built out of 10 NAS system dispersed across the globe, so how do you decide how you write
this is all with objectives. So a policy and IT administrator can set an objective for this class of data or this application. Maybe it lands on this storage first or moves to other storage secondly. All of that can be layered into the policies at a file granular level.
Is it SLO related? Do you measure the performance in the backend so to take some decision, or is it just location based? So I have 10 locations and I want, something here, something on the other side of the world, a copy or whatever it is.
Tony, you may want to jump in, but it can be workflow based. It can be cost based. It can be performance based, pre-staging for a workflow that is going to need high performance storage, and so you pre-stage an instance there.
I think.
Yeah, but do you know the performance of the system?
Yeah, so let me answer that question. So a couple of things. We actually do. We have we gather telemetry from the underlying infrastructure. So we gather all of the statistics about performance. So we do know which storage is faster, and so you could even create policies based on that and say, look, I'm not going to tell you what specific storage to put things on. Just I'm going to put a performance requirement in there and put these data sets on the fastest storage there is. And we use a financial arbitrage algorithm to make that determination. Everything has a cost, right? And so performance has a cost, locality has a cost, et cetera. So we do have that ability to use machine learning, if you will, in order to place data. But in the environment, you're going to have, you can be also very specific about where you store data and say, look, I want all of my data stored on this particular storage system in this environment. And that's where it gets stored on the initial writes. And then you say, and after 6 weeks of no access to that data, move it to an object store. And then you might want to say, hey, look, I want this data in these different locations because I have a collaborative workforce in another part of the world, and so I want to get a replicated copy there. But what will happen is that your rights in that local environment will be stored locally. And then will be moved to other locations, or instances will be sent to other locations based on what you want to get out of that data and where you need it to be.
Okay, the part of the question that I think Enrico asked that I didn't get an answer to is how dynamic and automated is this? Is this something that somebody actually needs to go push the buttons to make happen? Or is this something that that your global file system will figure out on its own and deal with on its own?
Yeah, so it can be fully automated, right? So that you can put in the policies in place, and let me simplify it. There are drop-down menus with very basic policies, and there are policies that are out of the box, right? They're default policies. So a user can set this up and use the basic policies in order to store data. You can then set up things for creating workflows, and again, for millions of files that can all be fully automated and part of an automated process. Or you can do things manually, so it gives you the flexibility to do both.
Okay, I mean, policies somewhat like vVols has policies where there's a bunch of different capabilities, and you need to match things up with what's available.
Well, it's useful maybe to think of the word objectives, because when you've got an objective about a certain class of data, or maybe a certain application or a workflow, you'll want that data to be treated maybe its copies, number of copies may be different than other classes of data, where it lives, how long it lives, how many instances there are. From the front side, it's still the same file, but on the back end, whether it's through the API, through the internal, pre-canned policies that are available, through things that an administrator may want to determine, all of these are part of the capabilities that enable them to tune the system to their specific needs.
Maybe